Hi everyone, I'm very excited to be here today to share with you about the topic about open source large language model optimization with Amazon SageMaker. My name is Haowen Huang. I'm a senior developer advocate at AWS. You know, as the generative AI continues to be popular, the optimization of large language models has also become a hot topic among developers, whether in the initial deployment or later when we fine-tuning. So today I'm going to share about LLM, which is large language model optimization, and I will also talk about how Amazon SageMaker optimize LLM's deployment and fine-tuning through two hands-on demonstrations. And here is the agenda for today. Today we will kick things off with an overview of the foundation models. First, we will discuss how to deploy an open source large language model like the Falcon-40B model using Amazon SageMaker. Considering the different abilities of developers, I'm going to provide two solutions. One of which uses Amazon SageMaker JumpStart, which only takes a few lines to deploy, making it the perfect way for entry-level developers to get into coding. Then, we will discuss fine-tuning open source LLM, such as the Falcon-40B model. Actually, it's a very challenging task. Because of the large model with 40B parameters, even some machines with multiple GPUs can't perform training jobs. Thus, we have to consider some of the most advanced methods, such as 4-bit quantization and PEFT fine-tuning. The next big challenge is real-time monitoring of the fine-tuning phase. We will show how Amazon SageMaker cleverly addresses these challenges. Finally, I will share links to the full code used today, as well as links to additional reference documents. If you are interested in getting your hands dirty after listening to my talk today, you can go back and experience for yourself. First of all, let's take a look at the foundation models. LLMs are all foundation models trained on large amounts of text data consisting of billions of parameters. This slide shows the difference between the foundation models and the traditional machine learning models. The nature and the general purpose of foundation models make them different from traditional machine learning models, which typically perform specific tasks. With traditional machine learning models, in order to achieve each specific task, developers need to gather labeled data, train, and deploy that model. With foundation models on the right side, developers can use the same pre-trained foundation model to meet the needs of different downstream tasks. Foundation models can also be customized to perform domain-specific functions within different businesses, using only a small fraction of the data and the computation required to train a model from scratch. Someone may ask me a question. So how do we know which open source large language models are performing the best? As shown on this slide, the screenshot on the left side is an open source large language model benchmarks leaderboard on HuggingFace. As we can see, the Falcon-40B is one of the best large language models to benchmark right now. Notably, Falcon-40B is an open source large language model with capabilities rivaling many current closed source models. So this is a great news for developers, as it opens the door for many exciting new use cases. And training a large language model with 40B parameters is very challenging. The screenshot on the right side is a blog describing how to train the Falcon-40B model on AWS. If you are interested in the details, you can follow the documentation link below the screenshot and to read more. Next, we will deploy the state-of-the-art Falcon-40B open source large language model on Amazon SageMaker. We know that many developers are maybe just starting out in the large language model domain. So how to easily deploy an open source large language model is the #1 job. So I recommend Amazon SageMaker JumpStart, which is done in 2 simple steps as shown on this slide. AWS has partnered with well-known foundation model providers to offer models such as the Generative models from AI21, Stable Diffusion models from Stability.ai, and the Falcon models on HuggingFace. Developers now can try out the models directly on the AWS console or deploy to machine learning instance on SageMaker. And the data and logs from these models stay in your account. As these models are deployed to SageMaker Inference, they are fully compatible with the full suite of SageMaker services and features. I really love this slide, and I hope you guys like it too. Yeah, the main code for deploying large language model using JumpStart is on the left, and the main code for deploy large language model without JumpStart is on the right. So we can clearly see that Amazon SageMaker JumpStart has greatly optimized the deployment of large language models. It provides a packaged element to help entry-level developers deploy large language models as simple as possible. As shown on the left, the JumpStart model function has basically completed the model deployment. On the right, we can see the many steps developers still need to implement if we choose another way to deploy the model. We will discuss it a lot. Now let's put it into practice. And there's a famous Chinese saying, 纸上得来终觉浅，觉知此事要躬行. So this is basically means practice is better than theories. In the first demo, we will use SageMaker to deploy Falcon-40B large language model and make inferences based on different downstream tasks. Let's open the SageMaker console, choose Studio on the left, and then click the Open Studio button. You are in SageMaker Studio now. In the Navigate panel, select Models, Notebooks, Solutions. This will open the JumpStart landing page. This page lists available solutions and models. Scroll down to find the Falcon-40B models in Text Models section. And select View Models, and the Models tab will open. Select Deployment Configuration to configure model deployment. And you can also select Security Setting to specify security configurations. And you can also find and select Open Notebook to run the example directly in Studio. The notebook kernel is now booted. Once we've started the notebook kernel, we can start running the sample code. In this demo, we will demonstrate how to deploy Falcon-40B model using the SageMaker Python SDK. First, we need to install the SageMaker Python SDK and IP versions. Then we select the model type and the versions. We use the Falcon-40B Instruct BF16 model as a foundation model. As we were explained with JumpStart, you only need to call the JumpStart model function to beam model deployment. If you are curious about what happened after running the deploy function here, you can go back to the console and see that the endpoint is now being created. As for the instance type deployed, AWS has tested models deployment on this instance type and it's still constantly being updated. Also, if you select an instance with 8 GPUs, you will need to make some minor changes to the code. The entire deployment process takes about 10 minutes. When you see an exclamation mark, it means the model has been deployed to the endpoint. Once you successfully deployed, if you return to the SageMaker console, you will see the status of the endpoint have changed from creating to in servicing. Then we get to an exciting moment where we let the Falcon-40B model make inferences on different downstream tasks. Let's take a look at how the state-of-the-art large language models performance today. The first is a question and answer task where we assign the LLM a question. Please introduce the 10 most beautiful sites in Sydney. We see that the LLM already has its output, and the Sydney Opera House ranks first. Maybe visitors can really take a good look at these 10 Sydney attractions recommended by the LLM. And there's also a section in this notebook that provided an overview of the Falcon model. It's pre-trained on the verbal text. It outperforms similar models and is available in 2 sizes. Falcon models can also perform other tasks, for example, code generation. Write a program to compute the factorial in Python. As you'll see, large language model has already output 120. There's also analytic task to answer questions, such like build a website in 10 simple steps, and some translation tasks such as translate from English to French. Next is the sentiment analytic task. We will provide a large language model with a paragraph to determine if the passenger is positive or negative. We have seen the model has a positive judgment on this passenger. And this is another question and answer task. The next task is recipe generation. We let the model output a recipe for delicious lemon cheesecake, and now the task is actually done. And the next is summarization task. We will provide a paragraph and ask the model to summarize the main points. I think it's very helpful for everyone in their daily lives and work. This section also describes the parameters that the Falcon model can use when performing inference, such as max length, max new token, etc. You can research it if you are interested. Once you will complete the demo, don't forget to delete the endpoint to save you money. You can also go back to the SageMaker console to check if the model's endpoint has been removed. And that's all for this demo. I hope you enjoy it. Through this demo, I think you will notice that deploying large language model using Amazon SageMaker JumpStart is relatively simple solutions for developers. And now that we've seen the large language models deployment demo, in the next unit, let's take a look at the fine-tuning part of the large language models. Amazon SageMaker can help you build, train, and deploy models for any use case using managed infra tools and workflows. There are many benefits to use SageMaker training jobs. I'm only going to focus on a few of them today. On the lower layer, we have infra, where SageMaker gives you access to the latest hardware, including NVIDIA GPUs and AWS training, as well as fast network interconnect between the instance, which is critical for distributed training. In the middle layer, we have the managed infra and the tooling capabilities. Amazon SageMaker takes care of large-scale cluster orchestration for you. It spins up the cluster, it spins down at the end. It helps with all the security and network configuration so that you can keep your customers' data and IP safe easily. There's also healthy checks at the beginning of the training job to make sure the hardware is functioning effectively and reduce the disruption to your training jobs. The orchestration also means that you only pay for what you use. You are only paying while that the cluster is up and training models for you, so that you don't have to pay 24/7 for all that expensive hardware. There are also tools for profiling, debugging, and monitoring your experiment, as well as for maybe like hyperparameter optimization with various strategies to make sure that you get the best models possible. In the top layer, we have frameworks and libraries that are optimized for AWS, such as PyTorch, TensorFlow, and HuggingFace, that are really easy to use on Amazon SageMaker, as well as SageMaker distributed training libraries that help you work with very large datasets or very large models. Since there are so many features that SageMaker can provide, I will select 2 optimization features to explain in detail next. I will also provide the full code implementation later. The first optimization related to fine-tuning large language models is quantization and PEFT fine-tuning. Typically, the full precision representation of LLMs don't fit into memories on a single or even several GPUs. To support an interactive notebook environment to fine-tune and run inference on models of this size, we use a new technique known as QLoRA. This is the efficient fine-tuning approach that reduces memory usage of large language models while maintaining solid performance. On the left side is the principle explained in the QLoRA paper. If you are interested in in-depth research, you can continue to learn by following the paper link below. Another new technique I would particularly like to mention is PEFT fine-tuning. With the PEFT technique, you can freeze most of the original model weights and replace or extend the model layers by training an additional, much smaller set of parameters. This makes training much less expensive in terms of required compute, as shown on the right side of this slide. Another hot topic about large language model fine-tuning optimization is how to monitor fine-tuning in real time. As you know, to monitor GPU usage in real time, we can run NVIDIA SMI directly from the kernel's container. To monitor the training metrics, we will utilize TensorBoard logs written to the specified S3 bucket. In the demo code I will provide later, you will find with just a small amount of code, we can easily launch TensorBoard on Amazon SageMaker console and perform monitoring fine-tuning tasks in real time. Using 4-bit QLoRA, quantization, and PEFT to fine-tuning large language model is a complex and cutting-edge topic. Finally, I would like to share with some serious developers who would like to be early adopters of the methods the following links, which is a related blogger for your reference. After listening to my talk today, if you are interested in learning more about large language model in practice, you can refer to the material above. Welcome to the world of large language models. And that's all for today. I hope you enjoyed the topic today about open source large language model optimization with Amazon SageMaker. Thank you very much, and see you next time. My name is Haowen Huang, and Haru for now.